Right, welcome to episode 5 of the series on software redundancy for S7-300 and S7-400 PLCs. Right, if you've missed the first episodes, there's a link up in the description. You can follow the first episodes there. Right, up to now, we've been looking at how the software redundancy works. And in the previous episode, we looked at a little bit about choosing which hardware we need for performing software redundancy. In this episode, we're going to look more closely at configuring that hardware. So looking at hardware config, if we just quickly draw a sketch of what we've decided on the hardware before, we've got some CPU with power, or some rack with a power supply, a CPU, and perhaps a communication processor, and perhaps some I/O, and another PLC, identical, also got a power supply, also got a CPU, also got a communication processor, perhaps. This is PLC-A, this is PLC-B, and one of our earliest design decisions we're going to have to make is how are we going to communicate between the two PLCs to talk about software redundancy. Now, straight out of the box, it's the most simplest way is via MPI. And the other way is by connecting these two CPs via Profibus DP. So we cannot use the Profibus DP of the CPU because that must be used for communicating to the ET200 stations. So out somewhere, either in the same cabinet or out in the field somewhere, we've got some ET200 stations, 200M, power supply, interface module. And this time we're going to start looking a little bit more closely at this I/O. So we might have an input card, digital input, and then we might have a digital output card, then an analog input card, an analog out, and so on. And something similar on the second station, where we've got power supply, we've got an interface module, another interface module, and then perhaps another digital in, and another digital out, another analog in, another analog out. Configuration of these depends on your application. So these do not need to be identical. They are in this example, but they don't need to be. Right, and then there may be more of these stations. There can be several. Right, let's take a look a little bit about these. We've already made the design decision between these two, and because they are both masters, well, not necessarily masters, but what we've got is two devices with addresses here. We need to make sure that they've got different addresses because they're on the same bus. So perhaps the MPI can be 2 and 3. Perhaps the CPs over here could be 5 and 6. Just for argument's sake, it's not necessarily exactly what they are. Then, coming off of our CPU on the Profibus DP network, we come out of here and go into the interface modules. And this likewise from this one over here to the second interface module. Now we can choose the addresses for these interface modules. We can either decide to call them the same number, n, or we can choose to call them n and n plus 1. So whatever design decision we make, whether it's going to be n or n, nn or n and n plus 1, the same must happen on all subsequent ET200 stations. So this then must also be nn or n and n plus 1, and so on. Right. Now going on to the actual addresses of these. There's an idea that comes up regularly when you look through all the manuals for software redundancy. That's the idea of being contiguous. In other words, a sequence, all the numbers must be in a sequences without gaps. Without gaps. Contiguous. This is very important on almost all the things, software and hardware. So let's take a look at these addresses for these interface modules. The interface module addresses, whichever one you start at, doesn't matter where you start, but every one after that must follow on without gaps. Now, I've just discovered an error on this. Don't look too closely. That is there, not there. All the interface modules these numbers must be consecutive. So it doesn't matter where they start, but every number after that must be 1 plus 1. If you're going to do NN, and let's say we start here at address 6, then this must be 6, and that must be 6. This must be 7, that must be 7, and the subsequent one is 8 and 8, and so on. If we're going to do n and n plus 1, then this must be 6 and 7. This one must be 8 and 9, and following on must be 10 and 11, and so on. Contiguous numbers. There cannot be any gaps. If there's a gap, the software redundancy will fail. Next, we've got to look. So, the Profibus addresses. Of interface modules must be contiguous. Right, now we can talk about the I/O itself. As we said before, this I/O itself is not redundant. There's only one module of each. It's only the interface modules that are redundant. It's protecting this Profibus network, but it's not protecting the I/O. But we also said earlier on that both CPUs can interrogate the inputs of these devices, but only one CPU, the master or the one in charge, can talk to the outputs of these racks. So only one CPU can do outputs, but both can read the inputs. What that means in the terms of software redundancy is that the inputs numbers don't really matter. And when you do configuration of your hardware, when you do it in step 7, normally what will happen is you'll get this number, the input, the first module here will get an automatic number somewhere in the low range, like input 0 or input 2, depending on if you've got I/O up here already. But you might have I/O byte 8 or whatever. Then all the inputs after that will follow on from that. So that one will be 8. All the digital I/O will follow on from there. So that'll be 8, and this one will be 9 or something like that. What they normally do in Siemens software is the analogs are normally done from 256 onwards. So digital start at 0 and analog start at 256 when you let Siemens do its own calculations and its own idea of what's important. But in software redundancy, all your outputs must be contiguous, which means that you are going to have to manually configure the outputs for the analogs to follow on the inputs. So you need to make sure that the input numbers are all contiguous. They start at some number, and this one is one more than this one, is one more than that one, is one more than that one, is one more than that one, and so on. Contiguous block of output bytes. So you may need to manually configure the outputs. So manually configure the output bytes in a contiguous block. So all the analog and digital outputs make one single block of bytes of output memory. Alright, so that's more or less all you need to do for the hardware config. Just make sure that your addresses are contiguous and that your I/O, especially the outputs, are contiguous, and that the outputs are all one after the other for these interface or for these ET200 stations. And we're going to have to choose, are we going to do MPI or are we going to do Profibus DP across a CP card? Because that will decide whether we're going to, which package we're going to use from the software that you get for software redundancy. I think that's enough for the hardware. So we'll stop here and then we'll continue with the software configuration in the next video. Thank you for watching. If you're enjoying these videos, please like and subscribe. We can continue making. There's more videos in another playlist about improving your software in Siemens stuff. Thank you very much for watching, and I'll see you in the next video.